Lesson 13, I will classify triangles based on side length, angle measure, or both. So today we're going to talk about how you can put triangles into groups. You can put them into groups based on the length of their sides or based on the measurement of their angles, or you can actually put them into groups based on both. So today we're going to talk about that. You're going to need to get out your Lesson 13 templates. You're going to have 3 of those, and you're going to see lots of triangles that are labeled A, B, C, D, E. You're also going to need a protractor, and you're also going to need a triangle. A ruler. You are not going to need your math journal today. So go ahead and get out your template. And your template, of course, has more than one triangle on it. And your practice sheet, you're going to need that too. Now, I've just taken the top part of the practice sheet off, and this just has triangle A. The first thing we're going to do is we're going to make a sketch of triangle A. So before we do that, let's go ahead and take our ruler, and we're going to actually use millimeters and centimeters. That is the side of your ruler that goes from 0 to 30. I want you to measure the sides of your angle, and I want you to write them on your triangle. And go ahead and measure from Z to X, and then come back. Okay, so as you measured from Z to X, if you use centimeters like I did, you should have found that this side was 13 centimeters. Go ahead and measure all the other sides of your triangle and come back. All right, after you've measured them, you should have found that this one was 13, and you also should have found that this one was 13. I want you to excuse my pen today. I'm having issues with my Smart Slate today, so I'm having to use the keypad on my laptop, so it's not working quite as well as it usually does. Okay, so each of these are 13 centimeters. So as we make a sketch of this triangle, we're going to make it right around this A. And I want you to try to make it with all sides as equal as you can. Obviously, you're not going to need to measure, but I want you to try to make it look like triangle A. Okay? All right, now I'm going to go to type here. Now it says attributes. So attributes of a triangle are the length of the sides and the lengths of the angles. So let's go ahead and let's measure the angles. Measure angle X, Z, and Y and label it on your triangle and then come back. Okay, after I used my protractor to measure all these angles, I found that these angle measures were all the same. Did you find them to all be 60 degrees? Because I did. So you should have put 60 degrees inside every single one of these angles. So 60, 60, and 60. So don't forget to put your degree symbol up there. I'm having some technical difficulties today, so I don't have it up there. All right, so when it says include side lengths and angle measures, the attributes. So what do you notice about all the lengths of the sides of this triangle? They're all the same, right? So let's put that here. So let's say all sides the same length. Gotta make sure that fits inside the box. And then let's say, what can we say about the angle measures? We can say all angles have the same measure. All right, let's make sure we can fit that all in here. Okay, so make sure you have that written in there. So we're going to come back to this classification in just a minute. So let's go on and let's move on to triangle B. Now triangle B is on a different page, so you'll have to flip to a different page. But I want you to do the exact same thing. I want you to measure all of the sides and all of the angles, and then I want you to come back. Okay, so here's what I found when I measured. I found that these two side lengths were 14 centimeters, and this bottom side length was 10 and a half. And this is how you write half in centimeters. And then I found these two angles to be 40 degrees, and this angle to be 70 degrees. Okay, so let's go ahead and let's sketch our triangle. And I'm going to make it look just like this one, so I'm going to make it tall. So it's going to look different than triangle A. Yours should too. Try to make it look tall and then have a nice straight side, okay? All right, so now when we list the attributes, we're going to say, make this a little bit smaller here. We're going to say, let's start with the sides. Now, they're not all the same like they were in the last triangle, right? This time we can say 2 of them are the same. So we can say 2 equal sides. And what can we say about the angles? Can we say 2 equal angles? All right, now let's go and do the exact same thing with C. So measure all the sides and all the angles and then come back. Okay, so after I measured the sides, I found that none of the sides were the same length and none of the angles were the same length. So let's go ahead and sketch our triangle. And remember, we want it to look like this. So this one's going to be a little bit harder to draw, but we're going to start by making this big obtuse angle. And then we'll come back. Ew, hopefully yours will look better than mine, but something like that. All right, now let's go ahead and write our attributes. So let's say no equal sides or angles. So nothing was equal, no equal sides, no equal angles. All right, let's do triangle D. Pause the video and come back after you've measured. Okay, so again, I found that none of the sides were the same and none of the angles were the same. But one thing I did notice that was different about this triangle is that it does have one 90-degree angle. So I think that that's important that we list that in the attributes. So let's go ahead and sketch the triangle. It's really important that when I sketch this triangle, I include that nice big right angle. All right, so let's make our right angle. And then let's go ahead and list our attributes. So let's say, instead of saying no equal angles, I'm going to say one 90-degree, or let's say one right angle. One right angle and no equal sides. All right, now let's go on to triangle E. So again, go ahead and measure all your sides and then come back.
Good morning, Audubon Welcome Bus 74.
Okay, so this time I noticed that I had two sides that were the same length and I had two angles that were the same length. So let's go ahead and sketch our triangle. Try to make this right angle. All right, and then when I say the attributes, this time I'm going to say one right angle and two 45-degree angles. All right, then let's say, that should say one, right? Then let's say two equal sides. All right, so we have one more left. So let's go ahead and measure angle F, all the sides and angles, and then come back. Okay, so on this last triangle, I noticed that I had two sides that were the same length, and I had two angles that were the same length, and I had this one obtuse triangle, or excuse me, angle. So let's go ahead and sketch our final triangle. Make sure that you include that big obtuse angle. And then whenever I say the attributes this time, I'm going to make sure that I really include that obtuse angle and those equal sides.
Welcome screen 2.
Okay, so let's say two equal sides, one obtuse angle, and two 35-degree angles. Okay. All right, now we are ready to take a look at all of our triangles and see if we can't classify these triangles. So just take a look at all of your triangles for just a minute and think to yourself, okay, what do some of these triangles have in common? Okay, this one has all equal sides and all equal angles. And this one has two equal angles and one equal side. And this one has obtuse angle. All right, so first of all, let's go ahead and label our classification right here. We're going to call this angles, and then we're going to call this sides, because remember, we can classify triangles by their angles and we can classify them by their sides. So if I just look at the angles on this one, every single one of these angles is acute. So we're going to call this an acute triangle. Okay, and I'm not going to write the word triangle, but this is an acute triangle if you just look at the sides. All right, let's look at the angles on this one. All of the angles on this triangle are acute, so this also is an acute triangle based on its angles. Let's look at this one. So we have two acute and one obtuse. So this is called an obtuse triangle. All right, now because this triangle has a right angle, we don't call it acute or obtuse, even though it does have acute angles. We call this a right triangle. All right, what do you think we would call this one if you just looked at the angles? Well, it's going to be like the last one. This is also a right triangle. All right, now this one has one obtuse and 2 acute. So again, we're going to call this an obtuse triangle. All right, now we're going to go back and classify all of these triangles based on their sides. Okay, now this has 3 equal sides. So we have a special name for triangles that have 3 equal sides, and we call this equilateral. Now, this one doesn't have 3 equal sides, but it has 2 equal sides. So we have a special name for triangles that have 2 equal sides. It is isosceles. Now this has no equal sides, so we have a special name for that. It's called scalene. So there's 3 special triangles when you look at their sides. And don't worry if you can't remember them all right now, because we're going to practice them on our problem set. So this has no equal sides, so this is a scalene triangle. Okay, this has 2 equal sides. So do you remember what we call it? We call it isosceles. All right, now let's practice. Oh, let's do this one. Okay, so this one has 2 equal sides. So this one is isosceles too. All right, now let's get to our problem set for today. All right, so it says classify each triangle based by its sides, lengths, and angle measurements. Circle the correct names. Now these little tick marks right here tell you that those 2 sides are equal. So if you just look at the sides, it has 2 equal sides. And if you remember, if a triangle has 2 equal sides, we call it isosceles. So go ahead and circle isosceles. Now if you look at the angles, it has 2 acute, but it has 1 obtuse. So we're going to call it obtuse. Now take a look at this one. Has 3 equal sides. Which one of these means 3 equal sides? You can go back and look at your practice sheet. 3 equal sides is called equilateral. Now look at these angles. Acute, acute, acute. So this is an acute triangle. It has to have all acute angles to be an acute triangle, because this obtuse triangle had 2 acute angles, but it had 1 obtuse. Because this has all acute angles, that makes it acute. Now look at this one. None of these sides look equal. There's no tick mark. So if there are no equal sides, we call it scalene. And then based on its angles, it has this one special angle, so we call this a right triangle. All right, try to do this one by yourself and then come back. All right, so because this has no equal sides, we call it scalene. And it has this one big angle here. So that is an obtuse angle, so this is an obtuse triangle. All right, let's keep going. Triangle ABC has 1 line of symmetry. What does that tell you about the measures of angle A and angle C? Well, if this is a line of symmetry, that means that everything on this side is exactly like this on this side. So what's that tell you about these 2 angles? Think about that for a minute. Well, it tells me that angle A and angle C are equal. That's what it means to be symmetrical. Triangle DEF has 3 lines of symmetry. How can the lines of symmetry help you figure out which angles are equal? Well, if this is a line of symmetry, then that tells me that this angle and this angle are equal. If this is a line of symmetry, it tells me if this angle and this angle are equal. So let's say, how can the lines of symmetry help you figure out which angles are equal? The angles on opposite sides of the line of symmetry are equal. All right, so triangle DEF has a perimeter of 30 centimeters. Label the side lengths. What do you know about this triangle? It doesn't tell you anything about the side lengths. It has no tick marks. But if every single one of these angles, if this angle is equal to this angle, and this angle is equal to this angle, and this angle is equal to this angle, that tells me that all of these angles are equal. So if all of these angles are equal, that tells me that all of these sides are also equal. So if the perimeter is 30 centimeters, then that tells me that each of these sides have to be the same. So think about that for a minute. If it's all together they equal 30, each side must equal 10 centimeters. So go ahead and label each side 10 centimeters. All right, use a ruler to connect points to form two other triangles. Use each point only once. None of the triangles may overlap. One or two points will be unused. Name and classify the three triangles below. All right, let's do these. Let's connect these together just because that way we will have the same information, okay? So I want you to go ahead and use a ruler to connect A to E, and let's connect A to B and B to E. So let's make triangle ABE, and then let's do triangle IHC. All right, so let's pick these together just so that we can have a chance to label them together. All right, so they've already done the first triangle for us. All right, now let's go ahead and put the name up here. So this is going to be triangle. Let's see if I can make a triangle. It's going to be kind of hard. All right, so triangle. Got to be a little one. I'm going to go and put my other triangle down here. All right, so triangle ABE. Let's do that one first. ABE. And classify it by its length sides. So this one is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. This one is 1, 2, 3, 4, 5, 6 units. And this one is 1, 2, 3. This one's got to be longer. So none of the sides are the same length. So what do we call that? We call it scalene. All right, now let's take a look at the angles. Are any of these angles special? Well, angle EAB is special. It's a right angle. So if it's a right angle, then how do we classify this triangle? We classify it as a right triangle. See if you can do triangle IHC by yourself and then come back. If you get stuck, you can always press play and I'll help you through it, okay? All right, so let's take a look here. Now, when I look at the sides, none of these are the same length. So again, this is a scalene triangle. When I look at the angles, I have two acute and one right. So this is a right triangle. All right, so let's take a look at number 5. List 3 points from the grid above that when connected by segments do not result in a triangle. So we've got to list 3 of them. So I'm going to do a dual page like this so I can go back and look. So what are 3 points that when you connect them, they do not make a triangle? What about these 3 points? What if I connected C, D, and G? Would that make a triangle? No, it would not. Okay, so let's go ahead and put that. All right, so points C, G, and E. Why didn't the 3 points you list result in a triangle when connected by segments? Why didn't they? They did not create a triangle because they form a line segment. When you have 3 points in a line, they're going to create a line segment and not a triangle. Can a triangle have 2 right angles? Let's think about that for a minute. So this is a right angle, and this is a right angle. So if I try to make another right angle, could I make a triangle? I cannot, right? So a triangle cannot have 2 right angles because it, having a hard time typing today, it would create a square or a rectangle instead. Okay, so remember there was a lot to learn today. Whenever you get ready to do your exit slip, come back and look at your practice sheet and come back and look at your problem set and hang on to those papers because you might need them in the future.